Hello, everyone, and welcome back to a new session for Computer Science 2. Today's session is to review Chapter 11, which is Structured Data or Structures. This session, we need to go over ADT, Abstract Data Types. Then we're going to define structures. Then we need to go over how to access structure members or member variables. Then we need to go over how to initialize structures. Then we need to speak about vector of structs or structures and how to access those. Next, we need to go over passing structures between functions. And last thing we need to know is speaking about pointers to structs or structures. Yeah, so first things first, what is ADT? ADT is abstract data types. In C++, you have data types that are primitive, meaning provided by the language, like integers, float, double. You as a programmer, you don't create those data types, you just use them. On the other hand, there are ADT, which are abstract data types that are data types created by the programmer. ADTs have their own range or domain of data and their own sets of operations that may be performed on those data. So you can create a data type of your own. You can give it your preferred name. You can call it whatever you want. And that data type is a group of members or a group of other data types. Right now, you know how to group multiple items under one data structure, which is an array. So far, you have seen in an array, you can group multiple variables in one data structure, in one element. However, in arrays, all the elements must be of the same data type. So in ADTs, you can create, similar to an array, you can create your own item or your own group or your own data type that has multiple member variables under it. And those member variables do not have to be of the same type. So ADTs, you need to know what is an ADT and the idea and the concept behind it. Abstraction, ADT, abstract data type. Abstraction is a general model of something. For example, the term dog is an abstraction. It defines a general type of animal. The term dog captures the essence of what all dogs are without specifying detailed characteristics of a particular type of dog. It's an abstract. It's an abstraction of a dog. So this brings us to refreshing on data types. What are the primitive data types? C++ has several primitive data types like Boolean, character, short, integer, long, float, double, etc. So abstract data types brings us to structures. Structures or struct. In code, it's called struct. A struct is is a way that C++ provides to you to allow you to group several variables together into a single item known as a structure. In the book, I have the book in front of me. In the book on page 615, you have table 11-2, variables in a payroll system. You can see you have a group of variables where each variable is of a different data type. we can group all those variables under one item called struct. And that's what you need to know. This introduces us to objects in C++ because a struct can be an object that consists of group of items. Everything is objects. So a struct payroll in this case is an object that has employee number, employee name, hours worked, pay rate per hour, and a gross pay. So this is what you need to know for structures. You need to know what is an ADT, sorry, what is the concept behind structures and the code, how to create your own struct. And then next we go to accessing data structure members. The concept here is to use the dot operator. So dot operator. This allows you to access structure members in a program. In case you don't know how to create your own struct and you don't know how to access struct members, I recommend that you go and read this topic 11.3, where the book shows you on page 619 how did they create in C++, how did they create the struct payroll, how did they define the members inside that struct, and then under int main, they created an instance of that struct. Then they populated it with values from the user, and finally, they displayed all employee data. And notice the dot where the instance name is being used with the operator dot in order to access each of the items inside that instance respectively. Next thing you need to know is comparing struct variables. But based on the book, they are trying to communicate that in order to compare two structures, you cannot say, for example, let's say I have instance 1, and I have instance 2. Both these instances are created from one struct definition. In order to compare if instance 1 equals to instance 2, I am not allowed to say instance 1 equals instance 2. This is illegal. In order to compare if two instances are equal, I need to go over their members one by one respectively. For example, in the case of payroll, oops. Oh, interesting. Here you go. So in order to compare, in this case, for example, payroll instances, I need to say explicitly if, for example, employee 1 dot imp number equals employee 2 dot imp number. Oh, and it has to be and employee 1 dot name equals employee 1 dot name and etc. So in order to compare if employee 1 is equal to employee 2, I have to go over their variables one by one respectively. I cannot say if employee 1 equals employee 2 because these two are never equal. Even if the variables under them are equal, these two instances in code, the name of the instance is not equal to the name, whatever the value being carried by this name. This, similar to an array, this might be the memory address. So I can't compare two memory addresses because they are never the same. Two memory addresses are never the same. As you remember, memory addresses are unique. Then the next topic you need to know is how to initialize a structure. So if you look at page 627, they show you in order to initialize a structure, well, this is initializing structure array. Let's go back to page 622, which is initializing a single structure. Notice I have a struct city info, string city name, string state, population distance. So 4 members under the struct city info. In order to initialize, meaning create an instance and give it a value, I need to say city info location equals, then curly braces, similar to an array, and then I need to pass values in order based on the definition. So if you look at the definition, the first member defined is the city name. So under the values, the first value is for the city name. The next value is for the state. The next value, which is 80,000, goes to the population, and the 28 goes to the distance. So in order to initialize a struct, they have to be passed in order. First member for the first parameter for the first member variable, second parameter for the second member variable, etc. Then they go for knowing how to initialize, how to create an array of structs or a vector of structs, and how to access those array. Simply, I can say, for example, if I have what the book is showing, on page 627, it's creating a struct called book info. So this struct has title, it has author, it has publisher, it has a price, and then in order to create an array of this struct, I simply say the data type, which is book info, the name of the array, I'm gonna call it my array, and then the size, let's say 5, semicolon. Similar to when you create an array of integers, you give it the data type, you give it the name, and then you give it the size. So similar fashion, I'm giving it the data type. In this case, it's an abstract data type, book info. I'm giving it the name, and then I'm giving it the size. So this allows me to do my array at, for example, index 0, meaning this will give me the first item in that array. In this array, the first item is not title, is not author, is not publisher, is not price. It's all of these. It's a book info item. So this will return an item, book info item. Then I can access it with the dot. Then I will get access to title or access to author or publisher or price. So by using the dot, I can access each of those along with the index. So I need the item at index 0, title, author, publisher, price. Or I need the item at index 1, title, author, publisher, price, etc. So if you don't know, so you have to know these in order, if in case you are not familiar, please go read the book and shoot me any questions or if you need help. Then they go for initializing the array. So just like you saw how to initialize a single struct, let's say book info. If I create a single struct, my instance, for example, if I create a single struct, the way to initialize it is by saying I can either do it on a different line, or I can do it here. So which, in my definition, which variable is the first? Title, then author, then publisher, then price, in order. So the first parameter I need to pass is the title. For example, in this case, I'm gonna say book info. Title, for example, C++. Author, for example, let's say me, string. Publisher, let's say library, some library, and then comma. Price, for example, I'm gonna say 200. Close curly brace, and then semicolon. So I initialized in order my instance. Similar fashion, if each instance takes a curly braces like this, then if I have an array of big book info, for example, I have book info, my array of size, for example, 3 equals open curly braces, close curly braces. Notice my instance takes a curly braces for itself, for the members in order, and here I have a 3, so I need to provide 3 curly braces as such. First one, I'm gonna say C++, publisher K, library 1, price 100, for example. Second one, I'm gonna say C#, H, for the author, lib1, and 200. And then for the third item, I'm gonna say, for example, Java, L, for the author, lib2 for the publisher, and then I'm gonna say it's 300. So I'm initializing all items for this array, and each item receives in order values for its member variables. So if I, in this example, I'm gonna keep it in front of us here. So if I need to display, for example, Java, I simply can say cout my array at position 2 dot title. This line will display Java because I'm telling it I need the item at position 2. This item is at position 0. This item is at position 1. This item is at position 2. So I'm accessing the item at position 2, and then I'm asking for the title, which is Java. Then the next topic they need you to know is to pass structs to or between functions. Similar to any data type, you can either pass by value or pass by reference or pass by pointer. So if I have a function, let's say it's a void that is called display, the parameter in this case would be book info. Just like we do with integers, we give it the data type, and then we give it a name. For example, a instance. Now that I received, or this function receives this item, I can simply say cout whatever a instance dot title. This will display whatever the title under this instance, under this book info instance. I can pass it by value like this, or I can pass it by reference, like we know with the ampersand, or I can pass it as a pointer, just like any other data type. There is nothing different. You give it the data type, either book info or book info ampersand for reference, or book info asterisk for pointers, and then you access it. Now, in case you pass it as a pointer, you can no longer use the dot, because dots are for values, and in case it's a pointer, you need to use the arrow operator. So in this case, it would be instance arrow title. This is one way. Or what you can do is you can dereference a instance. And remember, dereferencing a pointer will give you the value that the pointer pointing to. So I'm dereferencing a instance. Now this will allow me to use the dot operator, because this will make it or bring it back to a value instead of a pointer. So now that I got the value, I can access it with a dot. If I keep it as a pointer, then I need to access it using the arrow. Similar to passing book info or struct to a function, I can return book info from a function. So I can say, for example, book info pointer in this case, for example, let's say get instance. It doesn't have to take anything in this example. I can here create an instance book info pointer, my instance equals new book info. I'm dynamically creating a new instance. Then I can say, okay, read, for example, read values from the user. And finally, return this dynamically allocated instance. So return my instance. So this function created locally a dynamically allocated pointer. So means this instance will live even if the function finished, because it's dynamically allocated using the new operator. Before I used delete. The fact that I didn't use delete operator, that means this memory will live beyond the function scope. Then I populated it with values. I'm gonna read from the user and say my instance arrow title, my instance arrow publisher, etc. And finally, I will return it. So there is nothing really special with other data types. The same way you pass other data types, integers or double, you can pass them as value or reference or pointer. You can as well return, you can either return a book info or a book reference or a book as pointer. In case you're returning book info, which is not a pointer, you need to know that if you create it locally, it will die by the end of the scope. So returning a locally created instance will cause problems. You can return an instance by value only if you receive it from outside. So if you receive an instance and this function responsibility is to populate that instance, then you can return it back. So you receive it from the outside and then return it back. Receive the instance and then return it back. In case you create it locally, you need to remember that creating local variables without being static, without being dynamically allocated, will cause issues. If you don't know what I'm talking about, please read the topic again in chapter 9 about dynamically allocated memory, or shoot me questions and I will be more than happy to help you out. Yeah, this is it for the book. For structs, this is what you need to know before we start with intro to classes. Let me know if you have any questions.